In an arithmetic sequence, the 30th term is 102. The sum of the first 30 terms is 1,755. What is the sum of the first 20 terms? Well, I can use, if I know the value of the 30th term and the sum of the first 30 terms, I can use that to find what my term 1 is. If the sum is 1755 is equal to 30 terms divided by 2 times term 1 plus term 30, then I can say that 1755 is equal to 15 times T1 plus 102. Divide both sides by 15, and 117 is equal to T1 plus 102. And then I subtract 102 from both sides, and 15 is equal to T1. Now I know T1 and I know term 30, so I can figure out what the difference is. The difference is going to be 102 minus 15 divided by 30 minus 1, which is going to give me 3. Now I can solve for the sum of the first 20. I have 20 terms divided by 2, multiplied by 2 times the first term, plus 20 minus 1 times the difference of 3. The sum of the first 20 is going to be 870. In an arithmetic series, the first term is 11. The value of the last term is 119, and the sum of the first to last term is 1,235. Find the number of terms. Well, that's easy enough. If 1235 is the sum, it's equal to n divided by 2 times the first term plus the last term. Or 1235 is equal to n over 2 times 130. 9.5 is equal to n over 2, and then I just double it. There's 19 terms. For example 5, consider a geometric series in which the first term is -2, the third term is -72, and the sum of all the terms is going to be -18,662. Well, I can solve for what the ratio is given the value of term 1 and term 3. It's going to be the 3 minus 1 root of the value of term 3 divided by the value of term 1, or the square root of 36. I'm multiplying it by 6 every single time. Now I'm going to use this information in order to solve the number of terms. Because I know what the sum of the terms is, but I don't know the value of the last term, I'm going to say that it's going to be -18662 is equal to the first term times the ratio to the power of n minus 1 over the ratio minus 1. -18662 is going to equal negative 2 times 6 to the power of n minus 1, all divided by 5. Now I'm going to multiply both sides by 5 to get rid of the denominator. Negative 93310 is equal to negative 2 and 6 to the power of n minus 1. Which means that when I divide by negative 2, 46655 is going to equal 6n, or 6 to the power of n minus 1. Add 1 to both sides, and 46656 is equal to 6 to the power of n. And now, like we learned in the last lesson, we could just keep multiplying 6 over and over and over again until we get 46656, or we can say that n is equal to log of the answer, 46656, divided by log of the base, which is 6. And the answer is 6. There are 6 terms in this series. For example 6, when it asks us to determine the common ratio of a geometric series that has these partial sums. Well, if the sum of the first 3 is going to be this, the sum of the first 4 is going to be this, and the sum of the first 5 is going to be this. The only difference between the sum of the first 3 and the sum of the first 4 is that I added whatever the value of the fourth one is onto it in order to get the sum of the first 4 from the sum of the first 3, which means that the difference between these two values, or these two sums, is what the fourth term is. So I can state that term 4 would actually be the sum of the first 4 numbers minus the sum of the first 3 numbers. Or term 4 is equal to negative 105 over 16 minus negative 49 over 8, or negative 98 over 16 if I want to put them over a common denominator. Which means that term 4 has to be negative 16, or negative 7 over 16. The same would hold true here. The only difference between the sum of the first 4 and the sum of the first 5 is I added whatever term 5 is to get here. So term 5 has to be the sum of the first 5 minus the sum of the first 4. And if I put it over a common denominator, it's going to be negative 210 over 32. Which is going to give me negative 7 over 32. Now I can solve my ratio. The ratio is going to equal negative 7 over 32 divided by negative 7 over 16. The value of term 5 divided by the value of term 4. I'm multiplying it by 1/2 every single time.